For the introduction, magnetic resonance imaging, as known as MRI, is a non-invasive imaging technique that creates comprehensive three-dimensional anatomic imaging. It's frequently used to detect disease, diagnose them, and treat the process. It is based on cutting-edge technology that excites and detects change in the rational axis of proton in the water that make up biological tissue. MRI works. An MRI capture of imaging of the water content area in your body, and the detail in this imaging derives from how different tissue interact with the electromagnetic wave emitted by water molecule. The thought of water emitting electromagnetic wave may seem far-fetched, yet most molecules do it all the time. The signals they produce are so smart that you only discover them if you were looking for them. An MRI is just a device that simulates water molecules into release wave, then accurately records the position of those water. By sending a brief pool of weaker electromagnetic field, the MRI scanner purposely interprets the field. The protons are discreted by the weaker pulse pointing in a different direction than the continuous major field, causing them to become malignant with the constant field. The protons are left crowded after the full in, but they gradually re-arrange with the infinite constant field in a similar way to the multiply energy level of intron around an atom nucleus. The direction that protons can elevate has single, well-defined levels. The gradual rearrangement of the nuclear magnetic spin result in the emission of low energy radio frequency 14 just an electron in atomic energy level can absorb and remit photon while shifting energy level. Because the time and amount of arrangement varies depending on the thickness and hardness of the tissue in which the water molecules are settled. Careful monitoring of the arrival of limited photon in the MRI detector allow the location and shape of various tissue to be determined. Because the amount of water different part of the body varies, MRI detect the electromagnetic field of the atom in water molecules and ultimately this information to determine change in the density and shape of tissue across the body.
Basic principle of MRI. The basic of MRI is the directional magnetic field or movement associated with charged particle in motion. Nuclei containing an odd number of protons and neutrons have a characteristic motion or precession. Because nuclei are charged particles, this precession produces a small magnetic moment. When a human body is placed in a large magnetic field, many of the free hydrogen nuclei align themselves with the direction of the magnetic field. The nucleus precise about the magnetic field direction like gyroscope. This behavior is termed Lemma precession. The frequency of Lemma precession is proportional to the applied magnetic field strength as defined by the Lemma frequency. MRI scans work as an imaging method due to the unique makeup of the human body. We are comprised entirely of cells which all contain water, principally made of hydrogen ions. The magnet embedded within the MRI scanner can act on these positively charged hydrogen ions and cause them to spin in an identical manner. By varying the strength and direction of this magnetic field, we can change the direction of spin of the protons, enabling us to build layers of detail. When the magnet is switched off, the protons will gradually return to their original state in a process known as precession. Fundamentally, the different tissue types within body return at different rates, and it is this that allows us to visualize and differentiate between the different tissues of the body.
Assalamualaikum warahmatullahi wabarakatuh. My name is NADHIRAH binti ROSLIZAN with metric number S64407. How does MRI system produce image? To capture image, the MRI system will use and transmit magnetic waves to and radio frequencies into the patient's body. The energy emitted by atoms in a magnetic field will send a signal to a computer. Then, the computer will use a mathematical formula to convert the wave signal into an image. The patient should lie on the table that will move into the MRI machines for about 20 minutes for a spinal examinations and about 30 minutes for the legs, brain, and all other type of examination. Usually, the space for the table to move into the machine is rather narrow and compact. However, new technology has allowed a space for the MRI machine become more spacious and make it easier for patients to be more comfortable during examination. When the RF pulse is turned off, the proton moves in reverse and realign along with the magnetic field B0. If you think again about the compass, when we want to move a small bar magnet, the compass needle will rotate from east to north and parallel to the Earth's magnetic field. When a proton moves in reverse and realigns with B0, it will release energy. Different tissues in a patient's body will release different amounts of energy. To measure this emitted energy, we need some special equipment called a coil that is placed around the part of the patient's body that we want to examine. The coil acts as an antenna to detect the energy released as an electric current. The electric current is changed through a computer by using a mathematical calculation called the Fourier transformation, a mathematical calculation used to convert the electric current in a coil into an image. Since protons are in different types of tissue in the brain such as a grey matter, white matter and blood, all of them emitting different amounts of energy. The result of the changed energy is highly detailed image of the
Components in MRI. Active light structure, which is called the board, holds the components of the MRI machine in GT machine. It is similar to the gantry in CT machine. The board holds the following components. There are 5 components: magnet, gradient cord, shim cord, RF cord, and computer. The magnet function is the biggest and most important component of an MRI system is the magnet. We are dealing with an incredibly strong system here, one capable of producing a large, stable magnetic field. There are several different types of magnets that can be used to produce the magnetic field. Each has its advantages and disadvantages. Number 2 is gradient cord. The gradient cord functions when the MRI system is in a resting state and not actually producing an image. The magnetic field is quite uniform or homogeneous over the region of the patient body. However, during the imaging process, the field must be distorted with gradients. Number 3 is shim coil. One of the requirements for good imaging is a homogeneous magnetic field. This is a field in which there is a uniform field strength over the image area. Shimming is the process of adjusting the magnetic field to make it more uniform. Next is radio frequency coil. The RF coils are located within the magnet ensemble and relatively close to the patient's body. These coils function as the antenna for both transmitting signals to and receiving signals from the tissue. There are different coils designed for different anatomical regions. The 3 basic types are body, head, and surface coil. And the last one is computer. A digital computer is an integral part of an MRI system. The production and display of an MRI image is a sequence of several specific steps that are controlled and performed by the computer. The RF signal data collected during the acquisition phase is not in the form of an image. However, the computer can use the collect data to create or reconstruct an image. This is a mathematical process known as a Fourier transformation. This is relatively fast and usually does not have a significant effect on total image. The computer is the system component that controls the display of the image. It makes it possible for the user to select specific image and control viewing factors such as windowing and zooming. In many applications, it is desirable to process the reconstructed image to change their characteristic, to reformat an image or set of image, or to change display of image to produce specific view of anatomical regions. The advantages: MRI can be used for both physiology and anatomy. They are particularly useful for showing soft tissue structure, such as ligaments and cartilage. They can prove information how the blood moves through certain organs and blood vessels, allowing problems with blood circulation, such as blockers, to be identified. This is non-ionizing technique, which means no radiation.
Use of physics law in MRI. Magnetism is a property of matter that is the result of electron orbiting in atom. Orbital electron give atom a magnetic moment related to an inherent angular momentum called spin. Spin will be discussed in more detail later. However, the electrons are not actually spinning physically. The magnetic field in an magnetic resonance imaging scanner is generated by sound surrounding a coil of wire with supercooling fluid, lowering the temperature to about 10 degree K. Electrical current in the coil move very fast, creating the extremely large magnetic field. First, spin. In classic physics, rotating objects have a property called angular momentum. Angular momentum is a form of inertia that reflects the size, shape, mass, and rotational speed of an object. It is usually represented as a vector pointing along the axis of rotation. Atomic and subatomic particles possess as corresponding property known as spin or spin angular momentum. Proton, neutron, nuclei, and electron expose spin and are often represented as tiny spinning ball. Second, precession. In MRI, we are studying the behavior of millions of proton magnets. The net direction of their movement is called the net magnetization vector M. In equilibrium, M point in the direction of bow as more proton point along bow. This direction is often referred to as the z-axis. There is no polarization on the x-axis to y-axis. However, the proton actually rotate around this axis. So, any given proton will be pointing in a certain direction in the xy plane at any moment. The simple version of an MRI sequence involves so-called 90-degree pulse. This pulse of energy is just enough to rotate the proton by 90 degree. So the net magnetization rotate from Z to axis parallel to bow to the XY plane. At this time, the magnetization MZ along bow is 0. The spin is represented by the arrow. Notice the tip of the arrow precise similar to the top of the gyroscope. The spin allows absorption of a photon of frequency Vn, which is dependent on the strength of the magnetic field applied the nucleus. The conclusion is MRI or magnetic resonance imaging is a diagnostic imaging method that uses magnetic field and radio wave to produce a three-dimensional computer image. The history of MRI began in the early 1970s when studies found that the magnetic properties of atomic nuclei could be used to produce image of the human body. The MRI method applies the abundant proton source or in our body as a signal that will be detected and processed to produce a clinical image. Computer software that will process and reconstruct image according to clinical needs.
The tissue